All right, we're going to start with the renin-angiotensin mechanism. It is a blood pressure mechanism. It's designed to increase blood pressure in the event of severe blood loss or heart issues. So you'll start here first. This is like the cascade of reaction with blood clotting. A decrease in the amount of blood, either through injury, blood loss, heart not contracting properly, anything along those lines. Reduced blood supply causes the kidneys to release a chemical. Now, the cells in the kidneys are called JG cells, juxtaglomerular cells, and they release this chemical called renin. When renin gets released into the bloodstream, it actually is designed to cause a reaction with something called angiotensinogen, which is a plasma protein. It's produced by the liver. When renin and angiotensinogen come together, you get a reaction. And what happens is renin converts this into something called angiotensin 1, which doesn't do anything. But all this is circulating in blood, of course. When angiotensin 1, once it's formed, when it starts flowing through the lungs, there are cells in the lungs that produce an enzyme called angiotensin converting enzyme, or ACE, ACE. That's the enzyme it's talking about there, angiotensin converting enzyme, or ACE, ACE. That enzyme converts angiotensin 1 into something called angiotensin 2. Now, once that forms in the blood, it causes about 4 or 5 different reactions. It causes the arteries to vasoconstrict to offset the drop in blood pressure. When arteries constrict, the pressure inside goes up. It causes the adrenal cortex to release aldosterone. So that's going to make the kidneys conserve more sodium ions. And that was actually, we're not quite there yet, but we'll get there in a second. Wherever sodium goes, water's going to follow. It also causes more antidiuretic hormone to be released, which means antidiuretic hormone also is going to cause the kidneys to conserve water. And it also causes and it causes a person to become thirsty. But all those together cause an increase in blood pressure. So it's called the renin-angiotensin mechanism. Okay, as far as what regulates how much fluid is in urine, aldosterone, remember, is a mineral corticoid. It causes the kidneys to conserve sodium ions, and wherever sodium goes, water goes. So in the process, sodium is reabsorbed, and so is water. Antidiuretic hormone that's produced in the hypothalamus, but it's released from the posterior pituitary gland. It also causes the kidneys to reabsorb water. That example I showed you in the distal convoluted tubule and the collecting duct. All right, causes of diuresis. What causes kidney function to increase over a period of time? Yes, a large intake of water, consumption of large amounts of protein, lots of solids. Water has to be used to remove solids in the whole process of forming urine. So that's going to make more water in urine. Large amount of solutes, kind of same thing, solid particles. That's why if a person has a lot of glucose in their urine, they lose a lot of urine every day. That's why diabetics, a sign of diabetes is constant thirst and frequent urination. Caffeine stimulates the bladder. Alcohol causes the inhibition. It causes ADH to be inhibited. So it's not produced and released in the brain. So basically you lose a lot of water that way. And diuretic drugs. All right, last bit of anatomy, the ureters. These tubes take urine from the kidneys down to the bladder. And you'll see here they come down. This is the back of the bladder. This is called the seminal vesicles. You can see the ureters there. And then here are the openings that allow it to seep. So urine kind of comes down. And it's actually forced down. Ureters have a layer of smooth muscles by peristalsis, and it squeezes it down to the bladder. This is called the trigon, which is a flat part of the bladder. And the trigon allows that urine to flow toward what's called the urethra. So basically the ureters, yes, they connect the kidneys to the bladder and they empty in the back here. All right, on the ureters, up here are the kidneys. Already been there, done that. And then you can see coming down on each side, there's the right and the left ureters. I'm going to back this up so I can click on the bladder. So this is a male bladder, and you can see where these come down here, which are the ureters. Now I'm going to take away the vas deferens, which we'll get to that with reproductive. That's what, when a man has a tubal ligation, it's those tubes that are cut. But you can see here the ureters come around. They're emptying into the back. These are called the seminal vesicles. And I'll take away one side. I wonder if I can just, well, it's not going to let me. But you can go up into here and you can see right there. It says the urethral orifice. And that's where in the back you can see where it comes down. And that's how the urine gets into the bladder. It comes down and they both connect in the back like that. That's on the male. On the female, you see it comes down this way. See the short urethra, there's the external urethral sphincter. But same thing, this is saying the right ureter, the left. See, they would come in like that. And let me hide this. And you can actually see, that's a little better view. You can see the opening right there where it goes in. And I still have it hanging here in suspense. But you can see it on the other. If we go inside, there it is there. There's the, it says the right, well, anyway, that's the urethral orifice. And that's what it would look like in females. So the ureters come down and they actually empty into the back of the bladder. Okay, so onto the bladder, you can see here, this is the bladder, it's round, this is the back of it. This is called the serous coat, and then underneath that is the muscle layer called the detrusor muscle. So a couple things about the bladder. It does have rugae, you see the folds. It does have a thing called the trigon, which at the top is formed by what are called the urethral openings, where the ureter openings, I didn't mean to say urethra, sorry. The ureter openings in the back. The bladder does have some sphincters associated with it. But the detrusor muscle is huge. That's the part that starts collapsing and it tries to squeeze urine through the urethra. And it's a very strong muscle. Anybody who's held their bladder for a long period of time knows this. The longer a person holds their bladder, when the bladder gets full, it stretches. The stronger the contractions get. This is a male. Here's the prostate. Bad design. The urethra goes right through the prostate, and as men get older, that gets larger, so it squeezes the prostate off. Here is the internal urethral sphincter, which is made of smooth muscle. Don't have control over that one. And then here's the external urethral sphincter, and it's found in different locations in men and females. The female urethra is not as long as the male's. Females are more prone to bladder infections because of that, because it's closer to skin. But that's really the highlights of the bladder, the trigon. And then once the bladder fills up, it starts stretching, and there are nerves connected to this layer on the outside, and it can detect that stretching, and it'll cause the whole urine reflex and make a person feel like they have to go to the restroom to void their bladder. Yes, in inflammation, it's called cystitis. All right, here's a side view of the male bladder, and what this is here, this is the prostate gland. Bad design. There we can click on, it says the prostatic urethra, and then we can, there it goes through. And this is something called the ejaculatory duct which connects up here on the back to a seminal vesicle. Go over that in reproduction. So what I'm going to do, I'm going to take the outer layer of the bladder, and then this is the muscle layer I'm about to cut in half. So that big thick layer is called the detrusor muscle, and this inside lining of the bladder, the mucosal layer, remember it's a transitional epithelium. So there's the rugae, there is the internal urethral sphincter, and you can see on this diagram, if I click on the middle, maybe there, well, I'm going to back it up. You can tell, so urine would flow through here, and I say it's a bad design. The prostate, as men get older, can't help it, gets larger, and it starts pinching off the urethra going through there. So that means that bathroom trips become more frequent. It's harder to empty out the bladder or void it all at once compared to when people were younger, I guess. That little small, and I had just clicked on it. Let me bring this up. So right there is called the membranous. This is the prostatic urethra. Here's the membranous, very short. And then that layer right there, and I'm going to take away the erectile tissue. So right there, that's the prostatic urethra. Right there, it goes all the way through. And like I was saying, in men, it's further away from the skin, so doesn't mean men can't get bladder infections, but they're less frequent. So, in 3, 2, 1. All right, here's the bladder in females. Let me take away the bones so you can see. Well, one more. Let's take that away, and let's take that away. But if I click on this, it's going to bring it up, and once again, I can take away. That's the actual layer now, and you can see it if you can't see it on there. It says the detrusor muscle, a big thick layer in the bladder. We're going to cut that off. So there's the bladder, there's the rugae, there's the thick layer of the detrusor. And I know I had shown this earlier, but there's the urethra. You can see it's not very long. There's the external urethral sphincter. And then that's the neck of the bladder. And then right above that, in there, it's really hard to click on, is the internal urethral sphincter. But that's the male and female bladder. All right, the last part of anatomy. So urethra's here. That's the exit to the bladder. In males actually have 3 sections to it. It's called a prostatic, the membranous, and the penile urethra. Females just have, it's a shorter section of the urethra, but it's the exit to the outside. Okay, how about a quick tour, you're not going to hear this anywhere else, of sphincters. The ones that control, and what I'm going to do, I'm going to take away the bones. So now we have, that's kind of a cool view. So you can actually see at the top, see the kidneys. There's the ureters coming down. And then we're going to go here, so where the bladder is. Now I'm going to back this up. This, like I said, this would be a male. This is a male example. Let me do this one more time. I'm taking away the prostate. And then I'm going to take away the outer layer of the bladder, and then we're going to cut the bladder in half. So here is the rugae inside the bladder. You can see how thick the wall is. That's called the detrusor muscle. If I go down here and click on that, it says the internal urethral sphincter. You can see it right there. Maybe I can get it lined up. There it is. And you can see there's the exit. So this is the, like it says here, this is the prostatic urethra. So urine's full, and then that's the opening that the urine is leaving underneath there. So this little area of smooth muscle, it's called the internal urethral sphincter. This is under involuntary control. And this will actually loosen when the bladder starts to get full, what's called the Micturition reflex. When this gets full, that little valve here is going to release. Now, this is a smooth muscle. Human beings don't have conscious control over that. This one, and let's see if I can take away, let me see. There. And I'll show on females. Wow, those are the bulbourethral glands. It's amazing. Here, now, so, okay, that one up here I was pointing to, that one relaxes. So urine's going to flow down to here. Now, this little valve right there, now, of course, this is in men. The external urethral sphincter, now that one is made of skeletal muscle. This one, human beings have conscious control over, men. So that allows a person to wait to void their bladder. So even though the bladder gets full and that one relaxes, the urine would flow down to there, and that's the one that a person has conscious control over. Okay, so in females, let me give the female example for this. Let's go ahead and hide the outer layers. You can still see the rugae. You can actually see there, now it says the neck of the bladder. So there's the opening. And then down here, in fact, let's take away the ischium. And this is the pubis bone. There it is. There's the external urethral sphincter. Now you can tell in females the urethra is very short compared to males. That's longer. Males have a prostatic, a membranous, and a penile urethra. And if I go up here and click on where it says neck, and I hide that, but there where I just highlighted, you can see it. There's the internal urethral sphincter. And there's the external. So this is the one that's under involuntary control, smooth muscle, and then this one is the skeletal muscle one. So micturition. Micturition is the act of urination. And I'm just going to read this to you. Urination is normally prevented by voluntary contraction of the external urethral sphincter. You saw where that was. And one more time, it's showing it in that picture too. So as the bladder fills with urine, it says 150 to 300 mils, stretch receptors are stimulated, signaling the micturition reflex. Let's go to the tape. So here is a picture, and you can see on the bottom down here. Let me click on that. There's the bladder. And without me taking anything away, if I turn this around, you can already see, look at all the nerves that are connected to the back of the bladder. Now, if we take away the muscles and then we take away the bones, so now we have the colon in the back, and I think I could probably take that away. There we go, just to give you an idea. So there's the bladder here, the ureters, but you can see, look at all of the nerves that are associated with the outside. And they will detect the changes, they're called stretch receptors, and when the bladder is filling up. Now to back up, and I went ahead and took everything away, you can see here, look, this is the spinal cord. I can click on it, that's the cauda equina. The bottom portion of the spinal cord. So here's the spinal cord. It says dura mater of the spinal cord. I can actually take that off, and now you have the spinal cord. And you can see where it comes down here like this. Let me just click on the bladder. There we go. So what happens during micturition is this will start to stretch. You can see the nerves coming up. It's going to send a signal to the spinal cord there. For some reason, it doesn't want me to get close to the cauda equina. It's called that because it looks like a horse's tail. And for some reason, this program's like, no. Okay, so whatever. Well, you can see it there. So the signals are going to the spinal cord. It's a reflex. From the spinal cord, there's motor impulses that go right back. And I believe I can take off. There it is. So you saw that I took off a layer. This is the detrusor muscle, and you can see it's innervated. So it will cause contractions of that muscle, and I've already shown this a couple of times, and this was a male. So there's the internal urethral sphincter. So urine has flowed down to the bottom here, and the only thing keeping the bladder from voiding is the external urethral sphincter. And so urine has now filled up in that area. It's filling up here, and it's stretching more and more. And so the signals to, here's the spinal cord in the back, they're getting stronger and vice versa, and that's where the urge to urinate comes from. When that sphincter, when this is relaxed, is when a person can actually void their bladder, whether they're male or female. It's a conscious effort, relaxing the urethral sphincter, and then you go from there. All right, last bit of this, what's normal in urine and what's not. The color of urine is determined by what are called urochromes. They're biopigments from the decomposition of cells being broken down. Normal coloring is clear to amber. A person that's dehydrated, where there's very little water, it's going to be dark yellow. Urine is, most of the time, is acidic, 4.6 to 8. Now, 8 is basic, but urine is almost always acidic. Specific gravity is a chemistry term. It relates to a given amount of a fluid against the same amount of water. Which one would be heavier or lighter? Urine has solids in it, so it's heavier. So that's the numbers you get right there. It's 1 to 1.35 times heavier than the same amount of water. These terms here, polyuria means a massive amount of urine lost at one urination. You can watch Austin Powers, the very first one, when he got out of the crowd freeze and he peed for like 5 minutes. That's polyuria. Diuresis would be an increase over time, so like hours, that kind of thing. Oliguria is scanty output of urine. Kidneys are not functioning as well, and anuria is complete absence of urine formation, which would be a bad situation. What is in urine? 95% water, urea, uric acid, and creatinine. So the urinalysis. In other words, what's not supposed to be there? Okay, these are all things that should not be in urine. Proteinuria is excess proteins. Glycosuria or glycosuria, excess amount of glucose. Phenylketonuria. Phenylalanine is an amino acid, and some people cannot metabolize it. So it ends up in urine. Hematuria will be blood. That's a definite no-no. Ketonuria are ketones from the excess fat metabolism, such as in a diabetic. And microscopic exam is just looking at looking at urine under the microscope as a slide. Glomerulonephritis, say that 3 times in a row. That's inflammation of the glomeruli. So the filter, that gets inflamed. It can cause the openings to get larger from the inflammation and the damage, and then a person can actually pass red blood cells and things like that. Gout is a condition of uric acid crystals being stored into joints, some of the smaller joints, especially the big toe. Kidney stones, they actually form in the pelvis, and they are hard. They're calcium oxalate, calcium phosphate. It'd be like a rock, basically, and they're very sharp. And then cystitis is a bladder infection. All right, thank you for joining me for these little kidney videos. And next, we'll be going over reproduction. Thanks.
And that's the bottom line, because Stone Cold said so.